Hi ladies, in this second edition of the types of chemical reactions, we're going to get into single replacement reactions. So just like the name, it is going to deal with having one of our elements kick out another one. So in single replacement reactions, you are going to have one element replace the second element in the compound. So for example, let's look at this first equation. But instead of writing it as 2H2O, let's write it as 2HOH to make more sense. So we're going to have the potassium, which is our K. It's all by itself, so it's going to be the one taking the place in the compound, which is the second portion, because compounds have more than one element, don't forget. So this potassium is going to kick out our hydrogen and make it be all by itself so that that potassium can be in the compound. So what you'll see is in our product, you now have the potassium with this hydroxide and the hydrogen is all by itself. So whenever you are having one element replacing a second element in a compound, you're going to get a single replacement reaction. Now, if you want a basic generalized kind of like a formula for looking for single replacement reactions, here you go. So you would have your first one all by itself plus something in a compound. And remember, this one all by itself is going to kick out the other one that is in the compound so that it itself can make, can make the compound anew as a product and have the first guy be all by himself. So for this example, we have the letter A kicking out this letter B. And now letter A is in the compound and B is all by himself as the product. And this example is really fun to watch. If you took potassium and threw it into some water, you actually get fire as one of the byproducts. And in the solution here, you can see it's kind of cloudy as well. So it is kind of cool to see if you ever get the chance. But that single replacement reaction, once again, is only going to take one element and replace it in that compound. And you can usually identify single replacement reaction by noting that both the reactants and the products are going to consist of an element all by itself and one compound. So if you're to look at our potassium and water reaction here, you have two elements all by themselves. Remember, elements, they are just made up of one type of element from that periodic table. You could put your finger on it if you needed to. And then you have two different compounds. So those are another way of showing a single replacement reaction. So let's try writing one ourselves. So here we're going to take zinc. This guy's all by himself, and here is our compound. So it will be zinc that is going to be kicking out our copper, and copper is going to be all by himself in the product. So here we have copper all by himself, and now we're going to have zinc nitrate. So it would be zinc nitrate. And remember, if you're trying to figure this out, zinc is always going to be +1. And nitrate, remember I give you that lovely list of polyatomic ions. And then we use the cross drop down method to make our product. So 1 and 1 go down. Since we don't write our ones, we get our reaction there. Now there is one little tidbit that we want to make sure that you know. When you are doing a single replacement reaction, you want to make sure that the element that is doing the kicking out is more reactive than the one that is in the compound. So let's take a look back at the one we just did. Now, whenever you are trying to figure out if a reaction is taking place, you want to make sure that your element that is all by itself is higher on the list that is given to you. So here we have zinc up top and copper way down here. Since zinc is higher, this reaction will take place. If it was not higher than our copper, then the reaction would not take place. So we want to make sure that we are having more reactivity whenever it's the one doing the kicking out. So good rules to follow are, so the best way that I like to do is first underline the two metals, which is exactly what we did. We have zinc and copper. And then if the element, so remember our element is the one all by itself, is more reactive, meaning it's higher on this chart, than the one in the compound, which remember our compound is the one that has more than one thing from our periodic table, then the reaction occurs. If number 2 is not true, then no reaction is going to occur. So for example, if we were to have had silver and copper, copper is higher on our list here, so no reaction would have occurred. So for the most part, it is going to be the more reactive element, but you have to make sure every time, otherwise no reaction is going to occur. All right, that's it for me this time. See you next time.